So let's solve the next problem in the series. Here you've been told that you have a 20-sided die that is rolled repeatedly, and after each roll you may either keep the value and stop or pay $1 to reroll, right? Now you're asked the value of the game under optimal play. So it's basically asking you the expected value of the game, right? Like how we calculate for the last one, but that was a simpler case where you're just asked to find the expected value when you rolled once. So in this case, let's suppose that the expected value of the game under optimal play is V, right? How would we figure this out? So the setup would be something like this. When I roll a 20-sided die, these are my outcomes, right? I could have 1, 2, 3, all the way up till, let's say, 19, 20, right? I could have any of the 20 outcomes. Now, think of it logically. So I would have a certain threshold, let's say, let me call that K. I'd have a certain number K, above which, if I get a certain value, I'd just keep it, right? I'd not re-roll again. But below this K, if I get a certain number, I would re-roll again, right? I would re-roll again because I know that I could have I would have a net positive output if I just pay $1 and re-roll again, versus let's say I get a number above K in the first very attempt. In that case, I don't have to re-roll again, right? So that would be, that's the setup for this problem. And if I had to write this as an equation, right? If I had to write this as an equation, I'd simply use the equation that we use for any sort of an expected value problem. What I'd have is V equals 1 upon 20, because each of the outcomes could come with a probability of 1 by 20. And what are the outcomes? So till K, my expected value, till K, the averaged out value would be V minus 1. And after that, if I denote with the variable X, it would be X for each of them, right? So it would be 1 by 20 into K into V minus 1 plus the summation of all the numbers from this K. So that would be K plus 1 till 20, right? K plus 1 to 20 into X. So if I have to further solve this equation, I'd have my V equals 1 upon 20 into also, there's an important condition that I should have mentioned before. Your V minus 1 would lie between K and K plus 1, right? That's how we've set up the problem. It would lie between K and K plus 1. So that essentially implies that V would lie between K plus 1 and K plus 2. Why am I highlighting this? You'll see this in a bit, because that would help us figure out the value of the V and check if it's correct or not. So in this case, when I expand, the first part would simply be K into V minus 1, but the second part would be this is nothing but the summation of a series where the common difference is 1 and the first integer is K plus 1 and the second is 20. So it's essentially n by 2 into A plus L, right? Where n is the number of digits between them. So the number of digits would essentially be 20 minus K plus 1 plus 1. That would be n divided by 2 into A plus L. A is K plus 1 and L is 20. So this is what you essentially have. That would give you V equals 1 upon 20 into K into V minus 1 plus this would become 20 minus K, and the other part would be 21 plus K divided by 2, right? That's what you'd have. So if I further expand on this, it would be 1 upon 20 into K into V minus 1 plus, when I expand this would be essentially become 420 minus K plus minus K square. Sorry, that would be minus divided by 2. Now once we have this, let's try solving for V in terms of K, right? So what I'd have is 20V equals KV. So if I take the common denominator, it would be 2KV minus 2K plus 420 minus K squared, right? That's what I'd have. To be honest, I think, you know what, we don't have to bring it down here, because we can just push the KV to the other side first. So what I'd get is 20v minus 2kv by 2, so that would just be kv equals 420 minus 3k minus k squared divided by 2, right? So v into 20 minus k equals 420 minus 3k minus k squared divided by 2, and v would be equal to 420 minus 3k minus k squared divided by 2 into 20 minus k. This isn't divisible by 20 minus k, so let's keep it as it is for now. And there is actually no way to solve this. You can't really differentiate this because this is a discrete problem and not a continuous problem. So you wouldn't be able to differentiate this and get a meaningful result. But then what you can do is plug in values and check, and which is why the initial condition matters to us, where we arrived at this condition initially, where we would lie between k plus 1 and k plus 2. And now you'd see why that matters, right? Let's suppose I substitute k equal to 15, right? In that case, if k equals to 15, v would be equal to 420 minus 45 minus 225 divided by 2 into 20 minus 15 would be 5, right? This would give me the value of k as this would be 265, and then you would have 175. So 265, and then this would be 270, so 150 divided by 10, that would give me 15, right? So here I get 15, but does v lie between k and k plus 1? It actually doesn't, right? So I need my v to, in this case, v should be lying between k plus 1, which would be 16, because my k was 15, and k plus 2 should be 17. V doesn't happen to lie between them, so I cannot use this solution and I have to discard it. But let me check for a different k. Let's put k equals to 14. In that case, v would be equal to 420 minus 3 into 14, that's 42, minus 14 square is 196 divided by 2 into 20 minus 14, that is 6. What I get in the numerator is 420 minus 238, that would give me 182, right? 182 divided by 2 into 6, that which is 91 upon 6, which happens to be 15.166, so I'll just take it as 167. And in this case, my k was 14, so k plus 1 is 15, k plus 2 would be 16, and v happens to lie between these two, right? Because v is 15.167, so v happens to lie between these two, so our condition is also satisfied. So in this case, the value of v would be 15.167, right? So what does that give us, right? Under optimal play, right, and v minus 1 would be 14.167, right? So under optimal play, you would stop if you get 15 or higher, right? And you would roll again if you get something lower than 15, right? You would 14 or lower, you would reroll again. 14 or lower, you would reroll again. Basically, anything below 15, you would reroll again, and that is the optimal way of playing this game. I hope the method is clear. If you have any doubts, you can let me know in the comments below. Thank you.